Blow molding processes are the most popular methods used to produce hollow products out of thermoplastic materials. Blow molding evolved from the ancient art of glass blowing. Today, it is a leading plastic manufacturing process because of the wide range of plastic resins that can be blow molded and the many possible methods of blow molding. Blow molded parts range in size from the very small to extremely large parts. Bottles and containers are the most common blow molded products, but other items such as highway barrels, automotive components, double-walled cases, toys, medical items, and structural panels are produced. Blow molded products are formed from thermoplastic resins such as high-density polyethylene, medium and low-density polyethylene, polyethylene terephthalate, polypropylene, polyvinyl chloride, thermoplastic elastomers, polystyrene, polycarbonate, fluoropolymers, polyimide, and many other materials. Most thermoplastic blow-molded products are produced via extrusion blow molding using high-density polyethylene or HDPE, but there are many additional blow molding processes which include injection blow molding, biaxial stretch blow molding, and co-extrusion blow molding. These blow molding processes all use elements of either extrusion or injection molding or a combination of the two. In addition, these blow molding processes all share four common stages: plasticizing or melting the resin, parison production when referring to most blow molding operations, or preform production when referring to biaxial stretch blow molding, parison or preform inflation and cooling in the blow mold, and ejection from the blow mold. A fifth stage is necessary in extrusion blow molding for trimming and finishing the product. For the most part, blow molding processes all use the same blowing technique, whether it be through a blow pin, a needle, a stuffer, or core rod. It is in the production of the parison, or the preform, where these processes differ. The process of extrusion blow molding involves applying heat and pressure to thermoplastic resin to produce what is called the melt. This melt is then forced through a die to produce a parison, which is then dropped, trapped, or conveyed to an open blow mold for subsequent blow molding. Extrusion blow molding uses either an intermittent or continuous method for the formation of the molten parison. Intermittent extrusion produces a parison only when the blow mold is ready. These parisons are produced by using either a reciprocating screw or an accumulator and ram-style machine. Injection blow molding incorporates elements of conventional thermoplastic injection molding with blow molding and is generally more economical than extrusion blow molding for containers under a quarter liter in size and large production runs. Injection blow molding machines typically contain three stations: the injection station, the blow station, and the strip or eject station. The injection station is basically an injection molding machine. A ram, usually a reciprocating screw, forces the melted thermoplastic resin under pressure onto a metal core rod held within a closed, split parison cavity injection mold. After the outside skin of the parison has set, the parison mold opens, and the core rod carrying the parison rotates to the blow station. Once the core rod is in position, the blow mold closes. A trigger bar opens the core rod air passage. The air lifts the parison from the core rod except where it is held at the neck and expands it to the shape defined by the blow mold cavity. Once the part has cooled sufficiently, the blow mold opens and the part is indexed to the next station for stripping or ejection.